Hey friends, welcome to our YouTube channel ITN Technique Review, and in today's video I will show you the best important and most important things of engineering mechanics, the free body diagram. In this video I will show you the complete view and visualization of a free body diagram. That's in short we generally known as FBD. The application of free body diagram not only in engineering mechanics but in most of the mechanical engineering courses like in fluid mechanics. They need to solve any problem by fluid mechanics. Also in like thermodynamics, we also need free body diagram. That means how the system isolated from the surrounding. And the most important thing in design part of mechanical engineering, in every design part of mechanical engineering, we need a free body diagram, and that's a very important concept also for the mechanical engineer. So in this video I will show you a detailed description of the free body diagram. And the first of all I have written a definition of free body diagram, you can see on the board. The definition of free body diagram is saying that it is an isolated view of a body which shows an external forces exerted on the body that include also the self weight. Self weight means the weight due to gravity of any mass. We consider an example. Suppose we consider example, if this is our earth and any body on earth having mass m, then we need to find how much then we need to find the external force. Then our system is this m mass, then due to self weight mg acts on the downward direction, and there is a reaction force due to earth exerts a reaction force on this mass. Then this is known as normal, and we can balance it. Sum of Fy is equal to 0. Then we get normal is equal to mg. Then FBD is a very important concept to solve any type of such type of problem. I will take another example. Suppose this is a table and there is a mass, and the force F is exerting on this body. Then there is chance of due to friction, a frictional force acts on the back side. Then I will draw a free body diagram. Suppose this one is mass m, and due to self weight there is a mg, and here the external force is F. As in definition it's tell that it is an isolated view of body which shows an external forces on the body including the self weight, and there is a frictional force on back side, and this floor or earth acts as a reaction on the body, that R. Then suppose we need to find the value of R, then we balance the sum of Fx is 0, sum of Fy is equal to 0. By equilibrium equations we can find the reaction. Suppose first of all we consider the reaction forces in x direction. Then here F minus F is equal to, there is a no motion. Suppose acceleration is 0, just tending to move. Therefore F minus F is equal to 0. And the second in F we consider in y direction. Then R is equal to m of g. As you know, frictional force is mu of normal. Here normal is R. Here R is equal to n. Then we can get the frictional force. F is equal to mu at the place of normal mg. Then we get frictional force F is equal to mu mg. If you want to find how much external force is acting F, then here the capital F is equal to frictional force F, and that we have already calculated. Now we will see the another example of free body diagram, how to solve free body diagram problems. Suppose a inclined plane and a body of mass m, and a force acting on F. Then there is a friction force developed at the surface of contact, and due to this surface there is a normal reaction n, and the mg always acts downward. So here mg acts downward. Suppose the inclination of this plane is theta from the horizontal. Then we consider this triangle. If this is theta, this is 90 degree, this one is 90 minus theta, and this one becomes the theta. Then mg of cos theta, this one becomes mg of cos of theta, and this one becomes the mg of sin theta. I will show you the clear view. Suppose this one is our mass on inclined plane, this is our external force, this is frictional force, this is the component of mg of sin of theta, and this is our normal, and this is our mg of cos of theta. Then we can balance by taking that, suppose this one is our x-axis, this is our y-axis, then we can balance. Sum of fx is equal to 0. I have considered in this direction x is positive, then f of minus frictional force minus of mg sin theta is equal to 0. Then in sum of forces in y direction is 0. Then what we get, normal n is equal to mg of cos theta, mg of cos theta. As I already told, f is equal to mu times of normal. Here normal is mg of cos theta. Therefore mu of mg of cos theta. We get frictional force. Now now we will substitute the value of frictional force in this equation. Then we get the capital F, external force, f of plus of mg of sin theta. Now we can substitute this equation. So we can solve any type of such type of problems using free body diagram, and this is a very good technique to solve all types of problems. That's include the mechanical design problems, or that's also for the fluid problem. So friends, don't forget to like, subscribe and share to get more videos of this type based on the gate preparation.